The purpose of this video slash PowerPoint is to help you set up your graph and then answer the questions for the relating volume and mass experiment that we've been working on this week. The first thing you're going to want to do with your graph is set up the scale along the mass of liquid added side, which is running along the vertical axis. Because our total mass ends up being greater than 100 grams, we have to use different measurements for our tick marks. So what the ones we'll use today, or the ones that work best, would be is if you go up by 12. So you want to set up your axis like that. So there go reads 12, 24, 36, 48, 60, 72, 84, 96, 108, 102. The next thing you might want to do to make your life easier for placing on your grid is just take your ruler and add the grid lines at 12, 36, 60, 84, and 108 so that your grid looks like this. It's just going to make it easier to place the grid, your dots, that's all. Then the next thing you're going to want to make sure you do is put your legend along the bottom. You can see here that the legend, we have green to represent our water numbers. We're going to make a line that's going to be red to represent seawater, and we will make a line that is blue to represent the weights of the masses of the corn syrup. You can use different colors. You don't have to use green, red, and blue. They're just ones that I happen to have, so they're the ones I chose. Then the last thing you need to do now is start graphing your data. So for the regular tap water, when we had 10 milliliters, we had about a mass of about 9. So we come over to our 10 milliliters on the bottom, follow that line up to about where 9 is. So 9 is about 2/3 of the way to 12. So we would put our dot kind of right there. And then we would go on to the 20, and we would put our dot for that one, which is 18 and a bit. So that is kind of roughly halfway between 12 and 24. So I would put my dot there. If you get a messy dot like mine, just erase it and place your dot again. And then you just repeat that procedure over and over and over. The placement doesn't have to be picture perfect because it's really hard when you're dealing with a scale of 12, but roughly it should be fairly accurate, right? Like the point can't be, for instance, the next point I think is somewhere around 28, so I can't really have my dot way up here at the 36. That wouldn't be representative of it, right? I have to be sort of somewhat close. So I'm going to make sure that I'm more like down at this end. And as you go along, you're going to find that you will have some dots maybe a little higher, and some dots maybe not quite so high, like that. But as you go along, you basically are going to be increasing at a somewhat regular weight. Okay. Now, don't pay any attention to the exact location of my dots here at the end for right now. I'm just starting to place them because I want to talk to you about how to do your line of best fit. So, but we did know that with the first water one, we were basically adding about 9 milligrams. We were going up at about 9 gram increments as we went through. All right. So then, to do your line of best fit, what you would do is you would put your ruler and line it up so that approximately half of your dots, or not half your dots, you'd have the equal number of dots above the line as you have below the line, and you would just make a straight line. And your straight line can go from the x-axis straight off the page. Now, I will make a line, but it will not be straight because I have no way of putting a ruler on my PowerPoint screen to come across. Okay. but it would look something like that. So you can notice that I have a couple of dots above, a couple of dots below, some dots touching the line. That's all that a line of best fit is. The idea behind it is it's just going to give you a general trend or sort of idea of how the line is growing. So what I want you to do now is just pause the video, set up your graph the way I have it set up, put in your information, your dots for your water, then put in your line of best fit, get your second color, do your seawater, same thing, repeat it, place your dots, put your line on, then get your third color, place your dots for your corn syrup, put your line on. Okay, and then when you've done that, come back to the video and we'll talk about how to answer the questions 1, 2, 3, and 4. For question number 1, why did you measure the mass of the graduated cylinder at the beginning of the experiment and not after the liquid was poured out? Really, this is just kind of like a 1 or 2 sentence question. And what you want to do is you want to talk about what's left in the graduated cylinder after you've used it that would not have been in the cylinder before you used it. Okay, so think about like anytime you've had a drink. Before you fill the cup, the glass is empty. After you've drank your cup, is the glass all the way empty, or are there things left over in it? And then the other thing you need to kind of add into your answer is, how would those leftover bits affect your measurements of the amount of mass in each of your milliliter increments that we added to the water? All right, so let's look at number 2. To answer number 2, we're going to need to use our data table, and we were going to be adding numbers to the another question here. So number 2 wants us to calculate the mass of 1 milliliter of each liquid by calculating the mass of 1 milliliter of liquid from each 20 milliliter amount that was added, then taking the average. So it's kind of wordy, but it's really pretty simple. What you do is you come over to your chart, and at water you go to where the 20 milliliters is. Okay, and then you go to your 20 milliliter measurement, which in this case is 19.1. Okay, and there's a little arrow coming over. What we're going to do is we're going to do some math over here, and all you do is you take your 19.1 number and you divide it by your volume, which was 20. That gives you your measurement of 109.6, and that number then just gets written in your table right there. And then you just repeat the same procedure for when you have 40 milliliters and 38.7. Okay, so 38.7 divided by 40 equals 1.97, and then you would do 58.4 divided by 60 equals 0.97. Then you do 79.0 divided by 80 equals 0.99, and then lastly you would do your 99.1 divided by 100, and you get your last average of, your last number of 0.99. Then, so the last thing you were asked to do is to calculate the average here. So that's actually pretty easy. All you're going to do is you're going to add up your numbers here, your 0.96 plus 0.97 plus 0.97 plus 0.97 plus 0.99 plus 0.99. Divide that by 5 because there's 5 numbers, 1, 2, 3, 4, 5. And you've done that, you get an answer of 0.98. And that goes in your average like that. Okay, so now would probably be a good time to pause the video, fill in your chart for number 2, and then come back to the video. Okay, for question number 3, how do the mass to volume ratios for the 20 milliliter and 60 milliliter volumes of each liquid compare to your answers in number 2? You're going to need to look at, again, the data table, and you will also need your chart that you did in number 2. So really what they're asking you to do is they are specifically asking you to talk about the ratio of this number to this number, okay, which would be, if you were writing it in fraction form, you would write that as, you'd write that as 19.1 over 20. And then you'll compare that number to the specific number you had for here, which was per milliliter, right? So that would have been, I think our first one was 0.9697. So that'd be 0.97 over 1. So then you just kind of want to say whether these ratios are sort of equivalent or how they compare. Okay, so they want to talk about how they're the same, how they're different, and that's what they want you to do, okay, for question number 3. So again though, but you got to do it for the water, so you would do it at 60 here. Do it at 60, and then you'd also have to do it for corn syrup and for the salt water numbers. Okay, so again, pause the video, go answer, make those comparisons, write that up, and then come back to the video. For our last question, the last thing they really want you to do is look at your graph. You had your 3 lines, or you'll have 3 lines that look sort of like this, right? They're going to be going in that upward direction. One line representing your water, the red line representing your salt water, and the blue line representing your corn syrup, whatever colors you used, right? But they really just want you to talk about, does this line represent what you talked about in your hypothesis? So for instance, in your hypothesis, if you had said that you thought the amount of mass would grow in a normal linear fashion, then this graph represents that, because the line is going in a straight way, and it's starts low. With a low volume, you have a low weight. As you add volume, you grow in a linear pattern, getting a nice straight line. Now, if for some reason you had thought that, you know, the weight was going to stay the same as you added volume, then you would have had a line that came kind of like straight across like this, which you shouldn't have, but that would be what that kind of line would show. If you had a line that started up here on the left up high and came down, that's a line of best fit that is showing that your mass is decreasing as you add volume. Okay, and you can get rid of those lines for a second. And then the only other really sort of type of line you could get would be like if you had a line that started low and kind of grew like in a big U shape like that. And then that is also showing growth, but that's showing something called like exponential growth, where you're basically more than doubling your growth pattern as you add. So your mass would be like more than doubling your volume as you went up. So they just want you to talk about how your lines go with what your hypothesis was. Okay, this is kind of like in the last two labs we did that. It's the same thing as when you were talking in your discussion area. Okay, so with that, you've answered all 4 questions of your lab. You can take some pictures of your work and send it to me, or if it's in a Word document and you've still done it on the Word document, you can actually just share the Word document or email the document to me without having to take pictures. All right, have a good day.